Sorry, Bismillahirrahmanirrahim. This is Engineer Irfan, and I'm the course instructor for this foundation design course. And the course contents has already shared with you guys that what we will be doing during this course, and different foundation will be designed in total 10 sessions, right? So let us move towards the session one. But before starting the session one, let me show you from where you can download the softwares and to install in your computers. So this is the website. This is Civil MDC, and we have to search it in the Google. And the first page we have to open, this is the civilmdc.com, and you have to click on this third one, CSI, ETAB, SAFE and SAFE. You can also search it in this website as well, but this is the quick access, and you have to click on this. So the website will open on which you can download the SAFE, ETAB, and all other CSI softwares very easily. And you can download any version of these software, and you can use it for the design, right? So this is the website in which you can download this is the latest one, ETAB version 20, and you can download it with the crack and total package, right? And you can find the SAFE software version 2020 and all other old version softwares of CSI, right? So the crack is also available with these files, but if the crack is not available, then you have to download the run as date software. And how you can use that run as date software, you can search it on the YouTube. There's many videos you can see. And if still you have any confusion or any difficulties in cracking the software, then you can contact me, or personally you can message me, and then I will guide you and I will share you those videos, or I will personally do a meeting with you to install those softwares for you, right? So this was the little information about the softwares. So let us go towards the session one. So in this session, we will be discussing about the type of foundations and the introduction, brief introduction to different codes, and the general discussion of design practice. And this general discussion will be time to time in each and every session, right? So the overall type of foundations are two types, which one is the shallow foundations and other is the deep foundations, right? So there are many other types, but I have written those which will be covered in this course. That is, in the shallow foundation, we will be covering the wall footing, isolated footing, combined footing, step footing, and the most popular one, that is the mat footing and raft footing used for the high-rise building, right? And in deep foundation, we have also the piles, which we will be designing in this course, which is used for the very high-rise buildings or for the loose soil if you have high water table. So you can use these piles. So let us move towards the type of foundation one by one. So this is the first one, that is the wall footing, which is normally you can see in your Zishan Ahmed. If you have any question.
Yes, sir. Just I wanted to know, can mat footing have a combination of piles also?
Okay. Zishan, if you please write down the questions, any question you have, you write it down with yourself. And at the end of each session, we will have our session for question answer. Then you can ask any type of question.
Okay. Thank you very much.
So the first one is the wall footing, and you have normally seen in your villages, in your town, for the residential buildings, for 1 and 2 story buildings. Normally these footings are adopted. So this type of foundation is designed for load bearing walls, just like I said, residential buildings and other buildings. And this footing is designed as a one-way slab, right? This design is according to the ACI code. ACI says that if you have the wall footing, and it is actually a strip. If you can see in this picture that this one, the second one, that you can see the strip, this is the longer direction and the width is the longer direction. If you divide this longer direction by the shorter direction, this ratio will be always greater than 2, right? So when you have this ratio greater than 2, that becomes it comes in the definition of the one-way slab. So you have to design this wall footing as a one-way slab, right? And the typical thicknesses which you normally use in the design practice is the 9 inches, 12 inches, and 15 inches. And the typical width is taken as 3 feet to 4 feet for the 9-inch wall and 2 feet for the 4.5-inch wall, right? So remember this, these are just typical thicknesses, but when you design your structure for the wall footing, you have to calculate these thicknesses as per the requirement, right? So I have written this note that footing widths depend upon the number of stories and bearing capacity of the soil, right? It means if you select the width, 3 feet width for the bearing capacity of 1 TSF, right? And the number of story is 1, so it will work. But if you keep this bearing capacity as 1 and increase the number of story to 2, then you have to increase this 3 feet width and so on, right? So this is how you design and decide the width and the thickness of the footing. Normally, the thickness of this wall footing is not an issue because there is no punching issue. Normally, the thickness of the footing is governed by the punching demand. But you already know, if you have done any structural course or you have structural design, on those area, on those footing where there is a wall, where that is a RC wall or a brick wall, there is no punching issue, right? So the second one is the isolated footing. This type of foundation is designed for the columns as a part of moment frame system or bearing wall system. You have seen that in normal residential buildings, that the all of the system is the load bearing walls, but in the car porch or any other verandas, they have provided some columns, right? So it can be as a with the combination of the load bearing walls, or it can be individual as a commercial plazas, or normally the for example, if you talk about the DHA, so normally the pillars are now going towards the frame system instead of the load bearing wall system. And this footing is designed as a two-way slab, because if you can see that the width and the length of this footing is almost equal, it will become the square footing. So if you divide those by the width divided by the length, so it will be always less than 2. So when the ratio is less than 2, so you have to design it as a two-way slab. And these, you can see the steps are provided just for the economy. And if you have the punching parameter coming in this depth, so you can decrease this depth and give it as a slope, so you can achieve the desired properties. The normal practice thicknesses for the isolated footing, and normally in Pakistan, and what we are doing in our design practice, is 12 inches, 15 inches, 18 inches, and as well as 21 inches if the grid size is very large, right? And typically 3x3 foot width is taken for 1 story and 6x6 feet for 3 stories, and so on. You have to calculate it as per your requirement, right? So the isolated footing width depend upon the number of story and bearing capacity, and the thickness of this isolated footing is depend upon the grid size. For example, if you have, let me write it here. For example, if this is the grid, for example, this is 20 feet and this is 20 feet, right? And this is the internal column. I'm talking about only this column, right? And this is the 20 feet, right? So this is the grid size what I'm talking about. So for this, the thickness of the footing may increase, but instead of 20, if you have 10 feet, so the thickness will be less. And in case of the 20 feet, the thickness will be large, right? So this is how you will decide the thickness of the footing initially, right? So this is the whole story about the isolated footing. Next is the combined footing. This type of footing is designed for column as a part of moment frame system and bearing wall system, right? And it is used for the residential as well as can use for the commercial purposes. And this type of footing is normally designed for the large grid size, which I have explained earlier. And this footing is also designed as a one-way slab, because you can see in the upper figure that the length of the footing is greater as compared to the width. So if you multiply this length by this width, it will be greater than 2. So when the ratio is greater than 2, so it becomes the one-way slab. So all those requirements as per ACI 318, which are for the one-way slab, minimum reinforcement and the minimum spacing and maximum spacing, so it will be applicable on this combined footing. And similarly, the sizes and thicknesses are taken typically is 12 inches, 15 inches, 18 inches, and 21 inches. They depend upon the grid size and the number of stories, right? Because the thickness do not have any relation with the bearing capacity, right? Bearing capacity is direct relation with the area of the footing, right? So this thickness is governed by the punching, and the area of the footing is governed by the bearing capacity, right? And typically 5 feet width are taken when the story is greater than or equal to 3 feet. So on this figure, it is done as a trapezoidal, so you can achieve the economy. For example, if the first case is that you provide the rectangular shape and then you provide the trapezoidal. So if there is less demand on this left column and there is no need to provide the overall area over here, so you can decrease that area. And if it is provided required in here, so you can provide it here, so you can achieve the demand or the requirements. So you can economize this combined footing as well, right? Again, the footing will depend upon the number of story and the bearing capacity. The next one is the strap footing, in which is nothing but it is called strap footing because of this beam. This beam is called as a strap footing. When you have the isolated footing and you combine those isolated footing with a beam, it is called a strap beam. That is why this foundation type is called as a strap foundation, right? And this footing is designed for the economy purpose, or the other purpose is for the eccentrically loaded columns to distribute the stresses, right? And the another important factor for this use of this strap beam is to decrease the punching demand coming from the building. For example, if there is a restriction from the architect or from the client that you have to use the maximum thickness of the footing 12 inches, right? Because below there is a soft soil or there is a water table, or they have already done the lean. So you are restricted to use only 12 inches thickness for this footing. So when you perform the analysis and you check the punching demand, so it will be greater than 1, right? If it is greater than 1, then you have to minimize it. What is greater than 1? And this is demand to capacity ratio. The demand to capacity ratio should always be less than 1 for the punching demand. So then you have to provide this beam. So when you connect this beam from column to column in this isolated footing, so there will be no punching of this column, and you will achieve the desired properties of the footing using this strap beam with 12 inches thickness and so on. This is what I have give you just a simple example. And again, this footing is designed as a two-way slab, and this beam will be designed as a floor beam, or the beam which we normally design in our building structures, right? Remember that this beam should not be directly resting on this soil, because if it is directly resting on this soil, it will not transmit any stresses from one footing to other footing, right? And again, the typical sizes are these 12 inches, 15 inches for the thickness of the footing. And the typical width is 5 feet, which is the story is greater than or equal to 3 feet, 3 stories, right? And the beam dimensions, the strap beam dimensions are normally taken as 12 plus 12, 15 plus 15, and 18 plus 16, depend upon the thickness of this footing. For example, if the thickness of the isolated footing is 12 inch, then you are restricted to take the the depth of the footing to 12 inches, and the rest of the width is your choice as per the requirement, right? So again, this note is same for this step footing. The next one is the mat footing and raft footing, which is very popular and normally used in each and every high-rise building. And this type of foundation is designed for high-rise buildings, that is commercial buildings, or it is apartments, or it is offices. And this footing is designed as a two-way slab as per ACI 31814, because if you divide the length and width by these ratios, so you will get the ratio of less than 2. So you have to design it as a two-way slab. In normal practices, what we do is the thicknesses of the mat are starting from 24 inches if the story is greater than or equal to 5 or 6 stories. So it's starting from 24 inches and it goes to 30, 35, 42, 48, 54, and 60. And it's the thickness is governed by the punching demand, and the punching demand is governed by the grid size. For example, you can see this grid, this is larger grid, and this the other one is the shorter grid. So this column will require less thickness of the raft, but these will require, or you can say this one, it will require more thickness, right? So it is depend upon the thickness of the punching demand, the thickness of the raft depend upon the punching demand. Right. So this was the whole story about the mat and raft foundation. The next one is the very important foundation, that is the pile foundation. If you can see it in the picture there, the superstructure, and there is a raft, right? So you can design it with the combination that there is a very loose soil, which have the, for example, the bearing capacity is 2 TSF, but the load is coming from the superstructure is 3 TSF. So it cannot bear this load, right? So you have to go for the piles. So the bearing capacity of this soil at this tip of the raft is 2, and the demand is coming from 3, coming from the structure is 3. So this one extra TSF load has to be resisted by using these piles. So it is the designer's choice whether it is used with the combination of raft, or it can use it as a with the pile cape, right? So this type of foundation is designed for high-rise building, commercial building, etc., when raft footing is not sufficient to carry the loads and there is a very loose, moist soil, right? So there are the two options which can be used by the designer: piles with raft, in which some of the load will be resisted by the raft and some of the load will be resisted by the piles. And the other option is the single piles or group piles, in which there will be a pile cape, right? So the length and size of the piles will be determined as per the requirement, right? And the sizes of and this information about the capacity or the length. Say that, for example, if I take the 40 feet pile, so what will be the capacity of the 40 feet pile and the size of the 40 feet pile, right? So this information will be given in the geotechnical report, and you will request the consultancy which will provide the capacity of these piles, and then you have to select the capacity and design your structure as per the requirement. The typical and the normal available molds for the boring of these piles are the 12 inches, 18 inches, 24 inches, and 30 inches. There is also possibility that you may go towards the 36-inch dia piles, right? And again, the pile cape thickness is governed by the punching demand, right? So these are the different types of foundation, and this is the end of this theoretical lecture. So if you have any questions, you can ask.
Sir, I asked the question, but it is already answered in the presentation.
Right. I have heard you earlier that you asked that whether we can provide the pile with raft or not. You can provide the raft with piles, or you can use the pile cape as well, right? So it's your choice.
Right.
Sir, how can we know that the load coming is greater than the bearing capacity?
If you have any confusion, or you can ask you the questions in English, in Urdu, in Pashto, in any language, you can ask the questions for the better understanding.
सर जो सुपर स्ट्रक्चर से लोड आ रहा होगा पाउंड पर फीट स्क्वायर में वो कैसे कैलकुलेट होगा और हमें ये कैसे पता चलेगा कि बियरिंग कैपेसिटी जो है वो उससे ज्यादा है?
ये हम कैलकुलेट करेंगे, आप आगे देखेंगे। इसमें हमने कुछ केस स्टडीज भी किए, ये सेशन 2 में हम उसको थियोरेटिकली डिस्कस करेंगे, लेकिन प्रैक्टिकली हम इसमें जब हम पाइल डिजाइन करेंगे, so then we will see that if there is a load coming from the superstructure, so then you have to calculate those load coming from the superstructure and divide those load by the available area of the raft, and then you have to compare those demand with the allowable bearing capacity. If the allowable bearing capacity is greater than the demand, so it is okay, but it is less than, then you have to go for the piles, right? So we will compare. Ji.
Sir, one question regarding the wall footing. Can we model the wall footing in software, or it is done manually? Or can we model the load so that it is then exported? Please guide in this.
We will be using software for all of these footing, that we will be modeling in ETAB or SAFE, whether in each software, whether you are using SAFE or ETAB, and we will be designing using these software. You can model your walls, and then you have to design these as per the requirement. You can also do manually, but now the time is gone for the manual calculations. Now it is the advanced era, and then you have to make yourself advanced to make use these softwares.
I will further clarify. Wall, I mean the masonry walls. Normally, shear walls are also part of the design. So, about the masonry wall, can we model them in the software?
You can model the confined brick masonry in ETAB, but there is no unconfined brick masonry model in ETAB, right? So whether you have to
confined can be modeled in ETABs.
Yes, ETAB can model the confined brick masonry for you, but it cannot. You can, if you want to only transfer the load from the superstructure to the walls, and then from the walls to the footing, then you do not have to design the walls. You are talking about the design, right? So design is something else for the brick masonry. So then you have to model the walls in the ETAB, and you have to select the material of brick masonry, so it will become the brick masonry wall. And then you have to apply the loads on the superstructure, and those loads will transfer to the loads to the walls, and then the wall will transfer it to the footing, and then you have to design those footing as a wall footing. Right. We will be doing this in our design of the wall footing.
सर मुझे एक और सवाल करना है।
जी करें।
यो जब दो आइसोलेटेड फुटिंग कंबाइंड फुटिंग, अगर दो आइसोलेटेड फुटिंग मतलब दो कॉलम का बहुत नजदीक है तो हम कंबाइंड फुटिंग प्रोवाइड कर देते हैं। इसकी बजाय हम स्टेप फुटिंग भी तो प्रोवाइड कर सकते हैं।
जी बिल्कुल, आप प्रोवाइड कर सकते हैं, लेकिन फॉर एग्जांपल आपके पास 4x4 आइसोलेटेड फुटिंग आ जाए और इन दोनों के दरमियान क्लियर डिस्टेंस आपके पास 1 फुट आ जाए, तो 1 फुट बीम आप किस तरह प्रोवाइड करेंगे? उसका कोई फायदा ही नहीं। तो इससे अच्छा ये कि आप उसको कंबाइन करें, तो आपके पास स्ट्रेसेस रिड्यूस हो जाएंगे, तो आपके पास उसमें रेनफोर्समेंट आप कम हो सकता है आपके पास।
ओके,
ठीक है। अगर आपके पास 3 फीट या 4 फीट का डिस्टेंस हो तो आप बीम प्रोवाइड कर सकते हैं, लेकिन अगर आपके पास 6 इंचेस या 8 इंचेस या 1 फुट का फासला हो, तो उसमें आप बीम को कास्ट करना, फिर उसकी जो फार्म वर्क है वो लगाना, तो डिफिकल्ट काम है ना फील्ड में। वो सारी चीज़ों को आप देखेंगे कि ये फील्ड में पॉसिबल है कि नहीं। तो इस चीज़ को आसान करने के लिए आप उसको कंबाइन कर लेते हैं और उसको ऐसे कंबाइन फुटिंग डिजाइन कर लेते हैं।
एक और क्वेश्चन, जब आपका प्रॉपर्टी रिस्ट्रिक्शन हो, आपका कॉलम बिल्कुल आपके एच पे हो, तो उस सूरत में तो हम प्योरली इक्वल डिस्ट्रीब्यूशन ऑफ फुटिंग नहीं दे सकते। आपका मतलब एच पे होता है आपका एक साइड, तो उस सूरत में आपका डिजाइन कितना मतलब डिजाइन कितना अफेक्ट होता है?
जी जी, आपके पास तो नॉर्मली आपके पास जो एज पे होता है तो उस पे आपके पास पंचिंग का इशू ज्यादातर आएगा। तो आप उसमें इस तरह करेंगे कि आप उसकी थिकनेस बढ़ा सकते हैं, लेकिन अगर आपके पास उसकी रिस्ट्रिक्शन हो तो आप उसमें स्ट्रैप बीम प्रोवाइड करेंगे। राइट, आपके पास जो पंचिंग पैरामीटर है आपके पास D/2 ऑन ऑल साइड ऑफ द कॉलम, अगर आप वो उसकी अचीव कर सकते हैं तो देयर इज नो इशू इवन इन द एजेस और इन द कॉर्नर ऑफ द फुटिंग। राइट, तो अगर आप उसको अचीव कर लेते हैं तो ठीक है, लेकिन वो अचीव नहीं होता तो आप उसकी थिकनेस बढ़ाएंगे। राइट, अगर आप थिकनेस नहीं बढ़ा सकते तो फिर आप उसमें स्ट्रैप बीम प्रोवाइड करेंगे टू ओवरकम दिस पंचिंग इशू।
Right.
Right, we will be doing this. I have already designed some of the isolated footing in which the corners, the edges, and the concentric columns, all of them are present. We will be discussing these one by one.
Right, sir.
Right, if there is no other questions, so I think we should move on towards the session 2. Right, the session
sir.
2 is also about the theoretical part of this course, and the session 2 is very interesting, that how you will decide which type of foundation is good for your structure. And there is some case studies, theoretical case studies, and we will be then in session 2 will in session 3 will be moved towards the design session using the softwares. Right, so let me stop this recording